Okay, so I got something a little different for you guys tonight. So this had originally started out as something I was just playing with for myself. I was just trying to learn about the SPI protocol. This ties into the instrument clusters because the EEproms on the instrument clusters are a SPI EEprom. It's used the M95020 EEprom. It uses SPI. It does not use I squared C to communicate with the MCU on the instrument cluster. So I was playing with it and trying to learn a little bit more about them, and I decided I'd make a video about it, uh, mostly out of response to something else I ran into this week, where I posted a comment on a Facebook group. A member of this group asked a question. He had purchased a 2002 Escalade instrument cluster from a junkyard and then swapped them out in his truck. And now his odometer was off because the wrong mileage. And he was asking, hey, my local dealership won't reprogram it for me. Where can I go to get it reprogrammed? A lot of people were pushing GaugeWorks, and I responded on there like, hey, they're pushing GaugeWorks and saying GaugeWorks charged like 160 or 180 to do it, which I think is kind of high to do that. But besides the point, I responded, it's like, hey, I can do it for you for 60 bucks. I think that's what I said. I was like, hey, I can do it for you for 60 bucks if you want, or here's a video of how to do it yourself if you want to attempt to do it yourself. And Zach responded. Zach's the owner of GaugeWorks. He responded to my post and said, "Why are you trying to make that look so difficult? There's no need to take apart the board, desolder it, and open a bin. Like, well, why on earth would you do that?" And that's just how I do it. I find it really easy to do, and there's a very low barrier to entry to doing that. So this is a $30 tool that you can do that with, and you'd need a soldering iron. So really, all is what you need to do that is a desoldering tool, a prom reader, the adapter to fit the EEprom in, and a soldering iron. So that's what you have to have. A hot air station makes it nice. An actual dedicated desoldering tool makes it nice, but you don't have to have any of those. All what you have to have are some basic tools that anyone that works on electronics should have. I know a lot of people may not have this, but this is cheap. This is a cheap tool to get. I'm kind of rambling on here, but long story short, he's like, hey, why on earth would you do it that way when you can go buy a $1,000 programmer and just do it through the serial port? Which is true. I don't think I've mentioned that in any of the videos. There are tools that you can use to program these that are dedicated tools. That's always what they can do is they can program instrument clusters, and you plug it into the serial port on there, and it'll do that. So kind of a rant here, but it's just me like saying like, hey, I do these videos to show another way to do it, show a low barrier of entry way of doing it. This is where any Joe Smo off the street can afford to buy this and do this himself, and that's why I posted the video to it. It was not to say, hey, this is so difficult, send it to me because it's just impossible for you to do. Because, yeah, if you want the easy way, go buy a $1,000 tool. That makes a whole lot of sense, like, why is he even trying to suggest that to the guy? But whatever. So back to the video, though, of what we're doing here. We're going to talk about the SPI protocol, and this doesn't really tie into the instrument clusters too much. This is more of just a fun little Arduino project here where we can take our Arduino and read a dump off of the EEprom here. So focusing in on this, wiring it up's pretty simple. So this one actually is one of the few Arduino projects where you're really not going to be defining a lot of pins. The only pin that you're going to define is the slave select pin, which I just on mine defined it as 10, but you can change it to whatever. So ST on here labeled it chip select, but chip select and slave select are the same thing. So with the SPI protocol, what happens is you can have multiple devices on the same meso and oh, I'm having a brain fart, but serial and serial outline, the meso and mosey lines, because it's backwards. All right, but back at it. So serial lines, you can have multiple ones on there, but every slave on the system or every chip needs its own chip select or slave select pin on it. Unlike I2C, where you can just put all of them on one line and they can all communicate. SPI protocol needs it needs its own dedicated chip select pin. So that's the one that you define in there. Everything else, the library for SPI in there has already defined them. So when you go ahead and plug them in, you're going to be using, we'll just go through on the chip here. Hopefully it will focus and you can see it. So pin 1 is going to go to pin 10 on the Arduino, which that is the slave select pin. So that could change if you so choose to adjust it in the settings. Then pin 2 is going to go to pin 12 of the Arduino, and then pin 3, which pin 3 is that is W, so I believe that's write protect. Yes, W's write protect. We're going to go ahead and just ground that pin. So we're just going to put that to ground. Then pin 4 is VSS, which VSS is ground on here. And then pin 8 is VCC, which is going to be your 5-volt pin. 7 is the hold, which is another one that we're just going to run to ground. And then pin 6 will go to pin 13 of the Arduino, and pin 5 will go to pin 11 of the Arduino. And those are, so going back to here, so pin 5 was D, and D is the data input, which is, that would be the master out, slave in, and then the Q, which is over here, which is pin 2, that is your master in, slave out pin on there. So yeah, we just used our normal data sheet here. It's a 46-page data sheet. We really only needed 2 pages of it, page 6 and 7. So always when you're trying to do any of these projects, pull up your data sheets. And then we're going to go ahead and switch screens here so that way you can see what's going on. Okay, so here we have the sketch pulled up, and this is a copy of the flash that's on there. This is just a bin file that I flashed to it before I started this, so we have this to compare to once we pull the data off with the Arduino. But let's come over here and look at the sketch. So looking at the sketch, first thing you're going to notice, we're going to include the SPI library to it, and we're going to define the slave select pin in here, or chip select pin, and it's pin 10. Then the next kind of important thing, so this is basically where the SPI magic happens. Kind of the important things to notice in here. I'm really going to oversimplify a lot of this because I'm not a programmer. This is a little out of my wheelhouse, but so here's where it does the transaction, and it's going to look for the most significant bit first, which is what the data sheet says that you should do on this one, and then it wants SPI mode 0. There's 4 different modes. There's really no reason to get into what those 4 different modes are in this video. Great Scott has a really good video on SPI, and he explains the 4 different modes in there, and he explains most significant bit versus least significant bit first in there. So I highly recommend you go watch his video after you finish this one if you want to learn more about SPI protocol. So then as we go down further into the sketch, you'll notice here we have the read command, so you just send this bit to it, and then it'll start dumping everything out of it. So that's the read command for it. And then we'll come back down here, define the UART speed, where it's just where the Arduino is talking back to the computer when we go into monitor mode. And we just go down, and here we define how far into it we want to read, so how many integers down it goes. We could, if this was a larger chip, we could put in a larger number and read further in. So that's about it. I put a 5-second delay on it so that way it's not just reading it over and over again. So let's go ahead and plug in the Arduino and upload this sketch to it. So I'm going to plug it in. Alright, we're plugged in. I'm going to go ahead and upload this. It may give me an error because I just plugged it in. Nope, we didn't get the error. So let's go ahead and pull up the serial monitor. And there we go, we've pulled it out. That's just because I didn't have it in there. Let's, there we go, let's clear this, let it run one more time so we just get a nice fresh one. And then I'll unplug it. Okay. Because it'll just keep running every 5 seconds, so let's go ahead and unplug it and compare this to the bin that I uploaded to it. So as you can see, it ends on the same register, begins there, and we have 17 Charlie 1 FF, 17 Charlie 1 FF, and the last row is all zeros, and it's all zeros. So we got, I mean, I'm not comparing the entire thing to make sure that we got a completely good read here, but I'm confident that that is a good read off of here. Obviously you can see that it puts it in the hex, which got the 0x and then the number. So that's pretty much how this works. It's a pretty simple program. There's not a lot to it. A lot of it's already done for you in the library. So you just include that library and just call a couple of commands out of it, like SPI transfer and all that. So that's one of the nice things about the Arduinos is it's pretty easy. It's all just C# and pretty easy to learn. Just because I have no programming background, and I've been able to play around with stuff like this. This particular sketch I was able to pull off of the Arduino forum. It had some syntax errors in it, like output was lowercase, so it wasn't working at first, so I just had to correct that. And then I just needed to change the size because they were trying to read a 512-bit, and I just changed it to 256. I think that was all I had to change on there to make this work for me. But I did make sure I read through it and learned from it, because if you just copy and paste everybody's code, you'll never learn anything. So really went through it, tried to learn a little bit on this one. I thought it was pretty interesting. In theory, you could read and write this. I'm not interested in going that far into it and trying to write to the chip, but I just wanted to show that you can dump it to there. If you wanted to learn how, you could definitely write it. I would say if you were going to try to write it, do an interface with it where the program, you would then have a separate program running on the computer where you would send over an entire bin through the serial, through the UART connection that you have going through the USB COM, and do it that way. I would not try to write out the entire bin myself in here and have it transfer it that way. But that's about it for showing how it works. It's a pretty simple project. It didn't take too long to learn, and I'd recommend trying to get into some of this yourself. Okay, so that's really all there was to doing this SPI connection through the Arduino and talking to it. Again, this project, just a quick fun project. Hook up the Arduino, read the flash memory off of there, and be able to look at that EEprom through the SPI protocol and learn a little bit there. This I wouldn't recommend as being a productive way of working on an instrument cluster. If you don't want to spend the $30 on this, they make like $6 versions of these, a little bit different. And then you could also get something like this, which is an FTDI chip. I haven't figured out how to use them yet. It's a new project for me. Just arrived in the mail a couple days ago. But these are capable of doing the JTAG. They're capable of doing UART. They're capable of doing I2C and SPI, from my understanding. So in theory, you could use this to program one of these, and you could use it to do some JTAG connections. Now these are made for 3.3 volt, but they're 5 volt tolerant. I don't know if that 5 volt tolerance means it can actually communicate well with it, or if it just means that the I/O pins on here are just tolerant to receiving 5 volts. So I don't know if this would be productive with the instrument clusters. I'll have to get into it a little bit and try it out myself. But the Arduinos are definitely 5-volt tolerant, so that's why I use the Arduino to do it. I didn't even try to use this. It's just been sitting here as something got in the mail recently. I'll try to play with it, and if I have any success, you might see a video on it because it's so cheap. You can get these for like $5 on Banggood or AliExpress. Okay, well, I hope y'all like this video. If you haven't already, go ahead and consider subscribing to the channel if you want to see some more of this stuff. And I hope you learned something. I'll see you in the next video.